Hi, hello students. Welcome to Infinity Learn by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn. I hope I'm perfectly audible and visible to each and everyone present over here. So today in this particular session, we are going to discuss about the next part of the chapter, classification of elements and periodicity in properties. The last class we have discussed about the introduction part of the chapter, right? We have seen the classification of elements starting from the Dobereiner's Triads, Newlands law of Octaves, Mendeleev's periodic table and Moseley's modern periodic table, right? So here in this session, we are going to discuss about these concepts. That's about the periodic table, right? Long form of the periodic table or the modern periodic table which we are used now, and the nomenclature of elements. For example, in the case of a periodic table, we will be having more elements, heavy elements, right? Whenever we have the elements have the atomic number more than 100, we will be using a separate naming method according to IUPAC. So we will be going to discuss about the nomenclature of these elements and along with the classification of these elements, how we are classifying those elements in the periodic table as different blocks, S block, P block, D block and F block elements. So we can start our session by starting the nomenclature of these elements. So these are the particular rule according to IUPAC, that is the nomenclature of elements which they are having the atomic number more than 100, right? So here we will be having some rules. First, we need to identify the roots. When we are discussing about the nomenclature of carbon compounds, we have seen some roots, right? Whenever we are having only one carbon, the word root will be meth. If you are having two carbon, word root will be eth. Similarly, if you are having the number of digits, right? If you are having a number of digits here, from 0 to 9, we will be giving some roots here. That will correspond to the atomic number, right? Then, when we are writing the name of the compound, at the end, we will be given IUM as the ending part of those names. Then for corresponding any simple, they will be having 3 letters. Let us explain with examples, then you will get a correct idea. So this is the word root. So what you are observing here, if the digit is 0, if the digit means the digit which is present in the case of atomic number. If the digit is 0, the name should be nil, N-I-L, nil, and the symbol should be small letter n. The first letter of nil will be small letter n here. Similarly, if you are having 1 is the digit, right? If 1 is the one of the digit in the atomic number, it should be given the name as UN, UN, and the symbol will be become equal to the first letter U. Clear? Then what about the case of 2? 2 means bi, right? Bi. Then the first letter B will be the abbreviation or the symbol for the element. Then 3, it will be tri, T. And for 4, it will be quad, Q will be the symbol. Then for 5, it will be pen and P will be the abbreviation or the symbol. Then for 6, it will be hex, H. And for 7, it will be sept and S. In the last 2 cases, okay, I will write down here. So these are the symbol for letter 8, right? Digit 8 will be oct or symbol will be O, and for 9 it will be N or symbol will be E. Now let us explain the naming of those elements with the examples. So what is our first step? This is our atomic number, right? We need to identify the name of those elements having the atomic number 105 according to IUPAC, right? So what we need to do first? We need to identify the digits in the atomic number. The first digit is 1, right? So what will be the name? What will be the word root for that? 1 in the box, right? It will be UN, right? It will be UN in the case of 1. Then what about the case of 0? 0 will be nil, right? 0 will be nil. And 5 is equal to pen, right? 5 is equal to pen. Then what will be the symbol or name? We will start from here. U should be capital first. Un, nil, pen, right? This is the word roots according to the digits. Then what we have to add? At the end, we need to add IUM at the end, right? So this will be our name of this compound. Name of this element with atomic number 105, that is un-nil-pentium. Then what will be the symbol? First letter U, right? Then N, then P. So U and P will be the symbol for this element with 105. I hope you understand. Now try to find out the name of this compound with the atomic number 108. What will be your answer? So again here it is 108, right? So digits will be 1, 0 and 8. So 1 will be un here, right? Then 0 will be nil. 8 will be oct, right? So this will be the word root according to the digits in the atomic number. Then what will be the name? Un, nil, Oct, IUM, right? IUM is the end here, end name here. So what will be the symbol? It will be UNO, right? UNO according to the IUPAC naming. Is that clear? Okay, this is a major part we have discussed in the nomenclature of the elements. Not the point, it is applicable only to the elements that is having the atomic number more than 100, starting from 101 to 108, right? So this is the data of the elements which is having the atomic number from 101 to 118, not 108, it is 118. 118 elements are present in the periodic table. So according to IUPAC, you can say that it is unnil anium, right? 101. Then unnil bium, 102, and the symbol is UNU. The main point you have to keep in mind that the first letter of the symbol should be capital. As you can see over here, right? This U will be capital in all the cases. Clear? Then, after the discovery of these elements, there will be some official name of these elements, right? That is Mendeleevium, Nobelium, Laurentium, Rutherfordium, Dubnium, Seaborgium, Bohrium, Hassium. So, if possible, try to memorize the name of these elements also, like their official name as well as their official symbol. Okay, I hope you understand. This is about the part of nomenclature of elements having the atomic number more than 100. Now, we are moving to our long form of the periodic table. So, what you are observing here? The longest form of the periodic table which we are using here, that is a modern periodic table. So what you're observing here, some columns and rows are present, right? So here you can say that there will be one, see, 7 horizontal rows are present, right? 7 horizontal rows are present in the case of a periodic table. These horizontal rows are known as the periods of the periodic table. Right? These are the basics of the periodic table. We will be having 7 horizontal rows known as the periods. Right? So I will write down here. These are our periods. Then what you are observing here? How many columns are present? If I am starting from here, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Right? So 18 vertical columns are present in the case of a complete periodic table. Those vertical columns are known as the groups of a periodic table. Clear? So how many periods are present? It's 7, right? How many groups are present? It will be 18. Now many of you may have confusion here, right? Why these are not considered as a row here? So this is a part of periodic table in which here you can see, right? After this element, after this lengthanum, all the elements are belongs to the same period only. These elements are, because of the limitation of the space here, we are considering this in the lower, bottom part of the periodic table. Here also, this is also considered as 6th period and this is also considered as 7th period. Okay, I hope you understand. So when you are asking about the periodic table, how it is classified, it will be classified into 7 horizontal rows known as the periods and 18 vertical columns known as the groups. Clear? Now we will be discussing detail about the different groups or blocks in the periodic table in detail in the next classes. Fine. Now we need to see the electronic configuration of all the elements in periods. So if you are asking about the first period, right? If you are asking about the first period, what you are observing here? This is our first period, right? I will highlight here. So this is our first period. So what are the elements present in the first period? Only 2 elements, right? That is hydrogen and helium. So 2 elements are present in the case of first period, that is hydrogen and helium. And the hydrogen has the electronic configuration of 1s1. I hope you must have idea about the subshells, right? Subshell electronic configuration, which we have discussed in the lower classes. So here in the hydrogen, the electronic configuration is 1s1, which means 1 electron is present in the 1s orbital of the hydrogen atom. Clear? Then what about the case of helium? It will be 1s2. 2 electrons are present, right? Because the helium is having the atomic number 2. That is mentioned here, helium has 1s2. Okay, I hope you understand. This is about the case of first period. Similarly, if you are taking about the second period, right? Second period, which is the first element in the second period. This is our second period, right? This is our second period. So this second period starts from lithium. It starts from lithium, right? Then it's end with the neon. So what is the electronic configuration of lithium here? It is 2s1. And in the case of neon, it is 2s2, 2p6. That is already mentioned here, right? Second period starts with lithium. And its electronic configuration is 1s2, 2s2. And the second period ends with the neon having the electronic configuration 2s2, 2p6. If you are counting the total number of elements in the second period, it will be total 8, right? You can just count from here. Lithium to neon, it will be 8 elements are present. Clear? Similarly, we are just giving the idea about the third period also here. So what are you observing here? Third period again has 8 elements. Third periods also have 8 elements from sodium to argon. Then what about the case of fourth period? In the case of fourth period, these elements are also present, right? In between these elements are also present, which means total 18 elements. Total 18 elements are present in the case of fourth period. Clear? We are just giving the idea of electronic configuration or the number of elements present in the different periods. 7 periods are present. In the case of first period, it is hydrogen and helium only. In the case of second period, it will be having 8 elements. Third period also it is having 8 elements. But in the case of fourth period, it will be having total 18 elements. Clear? Now what about the case of fifth period? Here, this is our fifth period, right? Starting from rubidium. Ends with xenon, right? Ends with xenon. Again 18 elements. Now, I have a question for you. What is the total number of elements in the case of sixth period? Just look into this periodic table. Just let me know what will be the answer for the question. What is the total number of elements present in the sixth period? Is it 8, 18 or 32? Okay, many of you may be having the answers like 18, right? But here I have already mentioned that these elements are the part of sixth period, right? These elements are the part of sixth period elements. So in total, it will be having 32 elements. Similarly, in the case of seventh period also, right? So that is mentioned here. In the case of sixth period, it is charged with cesium. And ends at lutetium to give 4F series. This is our 4F series. Whenever we are discussing about the D block elements, we will be giving idea about the what you mean by series. I mean D series, for F series and so on, right? What are the different D block elements and F block elements, right? So here in the case of sixth period, cesium is the starting element here, and the last element is lutetium, which means total 32 elements are present in the case of sixth period. And what about the case of seventh period? It will be starting with actin, right? Actinide. Then it is end with the lawrencium, actinide and lawrencium. So again, in the case of seventh period also, it is having the 32 elements. Right? I hope you understand. So these elements are the part of lanthanide series and these are the part of actinide series. In total, it is having 32 elements in the case of seventh period, which is starting from francium to lawrencium. Okay, I hope you understand. That is about the electronic configuration or the number of elements in the case of periods. Now we need to check about the electronic configuration of the elements, general electronic configuration of elements in the groups. Let's start with our first group, right? Again, we need to go back to our periodic table, right? So what we are seeing here, this is our first group, right? So what you're observing here, if I'm asking about the electronic configuration of hydrogen, in hydrogen it is 1s1, right? Lithium it is 2s1. Sodium it is 3s1. And potassium it is 4s1. Rubidium it is 5s1. And cesium it is 6s1. Then last one, francium it is 7s1. So what you're observing here, if I am putting the value of n is equal to 1, 2, 3, 4, we can say that the general electronic configuration of these first group element, this is the first group element, right? This first group element is having the general electronic configuration of ns1. Is there any doubt? So that is given here. In the first group element, they are having the electronic configuration, general electronic configuration of ns1. For example, if it is belongs to the first period, it is having the electronic configuration 1s1. If it is belongs to the second period, it will be having electronic configuration 2s1. Clear? Now, similarly, if you are talking about the second group, here, right? Second group, if you are observing here, you can say that the first beryllium is having 2s2, then magnesium 3s2, calcium 4s2, strontium 5s2, right? Barium 6s2 and radium 7s2. Again, it is ns2, right? General electronic configuration is ns2. Okay, I hope you understand. Then what about the case of next? Now, if I'm asking about, these are the group 13 elements, right? These are the group 13 elements, 13, 14, 15, 16, 17 and 18. In the Mendeleev periodic table, it is given as 3A, 4A, 5A, 6A and 7A and 0. But in the case of modern periodic table, it will be given as group 13, group 14, group 15, 16 and 17 and 18 respectively, right? So, if I am asking about the general electronic configuration of these elements, right? These group 13 to 18 elements, I can say that it is ns2, okay, ns2 np1, right? ns2 np1, or general for those elements is having ns2 NP1, right? NS2 NP1 in the case of group 13 elements, right? Group 13 elements. Similarly, if you are asking about the group 14 elements, it will be NS2 NP2, right? NS2 NP2. Then similarly, if you are asking about the last group elements, it is group 18, it will be NS2 NP6. Or general, we can say that from group 13 to 18, it is having the electronic configuration of NS2 NP1 to 6. Clear? Okay, I hope you understand about the electronic configuration. We will try to find out the electronic configuration of all the elements in the different groups here. If you are asking about the group 13, it is having a general electronic configuration of NS2 NP1. For group 14, it is NS2 NP2. Group 15, it will be NS2 NP3, then NS2 NP4 and so on. Which means that the general electronic configuration of group 13 to group 18 will be NS2 NP1 to 6. Clear? That's about the electronic configuration of these elements in the periods as well as groups. Here you can see that there will be 3 to 12 groups, right? These are the 3 to 12 groups. This is represented as 3B, 4B, 5B, 6B, 7B and so on, right? These elements are commonly known as the transition elements. We will be discussing later. So this is another case in which the elements are present in the D block. Clear? Now, we can discuss the classification of entire periodic table into different blocks. How we are defining any element as in S block, P block, D block or F block element. Let us see one by one. See here, right? So this is the modern periodic table now we are using. So if I am asking about these elements, right? This is our first group element, right? This is the first group element. This is the second group element and this is 3 to 12 and this is 13 to 18, right? So if I am asking about, if I am taking any of the elements here, it is sodium, right? This is sodium. So what you're observing here, what is the electronic configuration of sodium? What will be the electronic configuration of sodium? Sodium is having the atomic number of 11, right? So we will try to write down the electronic configuration here. It will be 1s2. Okay, I hope you must have idea about the subshell, how to write down the electronic configuration. So first orbital is 1s. In 1s, maximum 2 electrons are present. Then 1s2, then we are moving to 2s orbital. Again, it will be 2s2. Maximum electron that can occupy in the 2s orbital is 2 here. So 1s2, 2s2, then again 2p. 2p is having the maximum electron capability is 6. Then after that, it is moving to 3s orbital, right? 3s orbital, it will be 1 electron only. So that it will be completing the 11 electrons, right? So 1s2, 2s2, 2p6 and 3s1. Now just focus on the valence electron only here. Which is the valence electron here? I mean last electron. This 3s1, right? Which means the last electron is entering into the 3s subshell, right? 3s subshell. So I can define these element as an S block element, which means whenever in any element, the last electron which is entering into the which subshell, it will be considered as their block. So this is considered as an S block element. Is there any doubt? This is the same which is writing here, the element in which the differentiating electron or the valence electron or the last electron enters the S orbital of the outermost shell are called S block elements. In general, the first 2 elements of each period, belongs to S block elements, or we can simply say that group 1 and 2 elements are constitute the S block elements. Clear? So these are the first group element and this is the second group element. These first group elements are commonly known as alkali metals, and the second group elements are commonly known as the alkaline earth metals. So these first and second groups, the last electron is always entering into the S subshell or S orbital, right? So that is why they are known as the S block elements. Clear? Now, from here to here, right, group 13 to group 18, what you are observing here, different elements are present, right? Different elements are present here. So, for example, if I am taking boron, boron is having the atomic number of 5. So, it will be 1s2, 2s2, 2p1, right? So, what about the valence electron here? This is the valence electron, right? So, one electron is, last electron is entering into the p subshell. So, this is a p block element, p orbital or p subshell. So, it is a p block element, right? So, in general, we can define the block of any element in which the last electron or the valence electron is entering into which subshell. So, in the case of p block elements, the elements in which the differentiating electron or the last electron is entering into the p orbital of the outermost shell, that is known as the p block elements. Then in the case of general configuration, right, general configuration will be written as ns2 np1 to 6. We have already seen, right? Then in general, group 13, 14, 15, 16 and 17, 18, that is from 3A to 7A, and 0 groups constitute the p block elements. Is that clear? So similarly, if you are getting any element, you will try to write down the subshell electronic configuration. Then just check on the last electron in which subshell it is entering, so that we can define the block of that element, right? We can define the block of that element. Now, let us discuss about the D block elements. So in the case of periodic table, you will be seeing some elements in between these S and P block, right? In between these S and P block. So if we are define the groups here from group 3 to 12, right? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? 12, from 3 to 12 groups elements are present here. So what you're observing here, if you are trying to write down the electronic configuration, is here in the case of scandium, right? For example, if you are taking the case of scandium, scandium is having the electronic configuration of, atomic number is 21, so it will be so this will be the electronic configuration of scandium 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d. So whatever the last electron is here, here it is last electron is entering into the d subshell, right? D subshell or the orbital, d orbital or the last shell. So which means that this is constituting a d block element, right? This is the d block element. Clear? Then from group 3 to 12 constitute the D block elements, and these elements are present in between S block and P block of the long form of the periodic table, so that these elements are known as the transition elements. They have a transition from S block to P block, right? They have the properties, transition from the properties of S block and P block elements. So they are known as the transition elements. Then the general electronic configuration will be n-1, D1 to 10, ns1 to 2. Clear? This is about the D block elements. Now we are moving to the last classification of elements in the periodic table, that is F block elements. So what do you mean by the F block elements? We can just define, right? In which the elements that the last electron is entering into the F subshell or F orbital of the valence shell, we can call it as a F block element. For example, if you are taking same here, right? From here to here, these two period elements are known as the F block elements. So if you are trying to write on the electronic configuration, you can say that, just go to the periodic table, you can say that any of the elements, if you are taking any of the elements, the last electron is entering into the F subshell or F orbital of the valence shell, right? So that is why they are known as the F block elements. So F block elements can be defined as the elements in which the differentiating electron enters in the F orbital of the anti-penultimate shell, which means the last shell is known as the penultimate shell. Then, for example, if I am taking ns orbital, right, this is the outermost shell. For example, if I am taking 6s orbital, 6s orbital is our outermost shell, right? For now, the next one will be 5d, right? The 5d orbital, that is n-1 shell is known as the penultimate shell. Then n-2 orbital is known as the n-2f orbital is known as the anti-penultimate shell. If you are getting, just accept, otherwise you can just leave here. We are just giving the name of the orbitals, right? If you are having the n orbital, it is the outer orbital, and n-1 orbital is known as the penultimate shell, and n-2 orbital is known as the anti-penultimate shell. So in the case of F block elements, we can say that the last electron is entering into the anti-penultimate shell, right? Anti-penultimate shell. These are known as the F block elements. Clear? So in general, in the case of periodic table, the last two rows, right? Last two rows in the periodic table is considered as the F block elements, which is a part of lanthanoids and actinoids. We will be discussing later about the F block and D and F block elements in detail. Then you will get the correct idea about that. This is just an introduction about the periodic table, how we are classifying the periodic table into different blocks as S block, P block, D block and F block. Now we are going to discuss about how we can define the position of an element. For example, if you are giving the atomic number of an element only, right? So how we can predict whether it is in the first period, second period, or how to find out the group of that element, or how to find out the block of that element, right? So these are the rule or the point we have to keep in mind, right? So first thing, what we need to do first, whenever you are getting any element, right, you should have idea about their atomic number. Then try to write down the electronic configuration. Try to write down the electronic configuration, right? This is our first step. Now, what is our next step? We need to identify the subshell in which last electron enters. That will be our block, right? That will be our block. Now, we need to identify the group of those elements. For example, if you are getting that element present in the S block, right? Present in the S block. As we already know, in the case of S block elements, there is only group 1 and 2 elements. So, we need to identify whether it is group 1 or group 2. How we can identify? We can identify the number of electrons in the outer s orbital, right? Number of electrons in the outer s orbital. It will be either 1 or 2, right? Then, if you are getting p block element, just listen here. If you are getting p block element, right? We have written the electronic configuration here. We are just check the where the last electron is entering, right? This last electron is entering into the p subshell. So we identified that it is a p block element. Then, how to find out the group of that particular p block element? We need to identify, we need to add the number of electrons in the outer shell. Number of electrons in the outer shell. Then add 12. Then you will get the number of group, right? It will be group 13 to group 18. Then for d block elements, the total number of electrons in the n-1d subshell and the ns subshell. Okay, we will be discussing detail with the examples. Then you will get an idea, right? So this is about the group prediction of an element. Then last one, how to predict the period of an element, right? How to predict the period of an element. So as we already know, we have 1s2, 2s2, 2p6 as the configuration, right? So here the highest value of principal quantum number, which means n value will be the period of that element. N value will be the period of that element, right? Let us discuss with the example here. For example, if I am taking the element with atomic number z is equal to 20. So what we need to do? We need to add electronic configuration. So it is 1s2, 2s2, 2p6, right? Okay, this is the electronic configuration of the element with atomic number z is equal to 20. Which block element it is? We will be focusing about the last electron. For example, these last two electrons is entering into the s subshell, right? So this will be an s block element, right? This will be an s block element. Then how to predict the group number of a s block element? Identify the number of electrons in the s subshell. So it is 2 here, right? So group will be 2 here. Then what will be the period? The large number of n value here is 1, 2, 3 and 4. So n value is equal to 4 is the maximum here. So period number will be 4. Now from the periodic table we can identify which element it is, right? Fourth period, right? 1, 2, 3 and fourth period. Fourth period second group. Fourth period second group means this is the element calcium. This is the S block element, right? This is the S block element. So that we can predict the position of any of the element in the periodic table by using this rule. Clear? Is there any doubt? Similarly, try to find out the position of element Z is equal to 34. Try to write down the electronic configuration first. First try to identify the electronic configuration. Then check the last electron where it is entering, whether it is entering to P block, D block, P subshell, D subshell, S subshell or F subshell. Then find out the group number according to the block element and find out the period, right? Now here Z is equal to 24, right? Z is equal to 24 is a special case. We need to identify the electronic configuration there. So if you are trying to write down the electronic configuration here, it will be 1s2, 2s2, 2p6. Okay, this is a special case here. So what you're observing here, the last electron is entering into the D subshell, right? D subshell. So this is a D block element. Is there any doubt? Because it is a D block element, right? Because last electron is entering into the D subshell. So this is the D block element. Now how we can find out the total group number of this element? We need to add the number of electrons in S and D subshell. So it will be 5 plus 6, right? So group will be 6 here. What is the period number here? The maximum number of n is given here is 4, right? 4. So period is equal to 4 here. So which element it will be? Fourth period, right? Again fourth period, sixth group. Sixth group means this one. Fourth period, sixth group. So this will be the element that is known as the chromium. Clear? Chromium is the element which is having the atomic number 24 and having the special electronic configuration of 4s1 3d5. Okay, I hope you understand. Okay, that's all about the part of longest form of periodic table. First one we have seen about the electronic configuration of the elements with atomic number Z is equal to 100, right? Atomic number more than Z is equal to 100. There will be some rules to find out the name of those elements. Next, we have seen how we can identify the elements in a periodic table by using block elements, right? By using block, period and group. Now we can practice one or two questions based on the concept we have studied today. Our first question is, which of the following configuration corresponds to an inert gas? So what will be our answer? So it will be answer 2, right? So in the case of p block elements, we will be dividing the p block elements into group 13 to 18, right? Group 13 to 18. For example, group 13. So there will be special name of these group. This is boron family, this is carbon family, right? This is carbon family and this is nitrogen family. Otherwise, it is also known as the nitrogens. Then group 16 is known as the chalcogens. Group 17 is known as the halogens. The last one, group 18 elements are known as the inert gas or noble gas. They will not participate in the reaction. Inert gas or noble gas. So according to this inert gas or noble gas, their outermost electron should be, the total number of outermost electron will be equal to 8. So we need to identify which one is having the outermost electron is equal to 8 here. Which one is here? Here it is 7 electrons, right? Here it is 8 electrons. We are considering 2s2 and 2p6. This is the outermost shell electron. Then here it is 2s1, right? 1 electron. Here it is again 1 electron. So we will be considering the second element as the inert gas here. Clear? So what is the speciality of inert gas? The last electron, the number of valence electrons is equal to 8 in the case of noble or inert gas. Now we can move to our next question. The elements of a vertical column have same atomic number, same electronic configuration, same number of valence electrons or same number of core electrons. What will be our answer? Elements of a vertical column means it is the elements in the same group, right? Same group. Yes, option 3 will be our correct answer, right? There will be having the same number of valence electrons. Just go through the periodic table, try to identify the valence electrons in all the elements in the same group, right? You will get the correct answer here. It is the same number of valence electrons. So option 3 will be our correct answer. Here is our next question. Which of the following is an element present in the D block but not a transition element? Okay, maybe this will be little bit difficult. So I can say that cadmium is the answer, right? Option 1, cadmium is the answer, because cadmium, if you try to write down the electronic configuration of cadmium, we can say that the last electron is entering into the D subshell. D subshell. So it will be a D block element, but it cannot be considered as a transition element, right? So last electron is entering into the D subshell, but it is again it is a D block element, but we cannot be considered it as a transition element, because in the case of transition element, they must have incomplete, not completely full, unfilled D electrons, right? Here it is 3d10. The maximum possibility of filling the electron in the D orbital is 10 electron. I hope you must have idea about that. So here it is 3d10 completely filled. So we cannot consider it as a transition element. It is not a transition element. Clear? Similarly, zinc, cadmium, and mercury. These are the three elements which is belongs to d block element, but it is not considered as a transition element. So this is the next question. The element with electronic arrangement argon 3d2 4s2 belongs to which block? 3d2 4s2 belongs to which block? So option 3 is our correct answer. I know that many of you are giving me the answer as option 1, right? But the correct answer is D block here only, because in the case of these element, if you are writing the electronic configuration like that also, according to Aufbau principle, maybe you must have idea about that. So this is the Aufbau principle. Don't get confused here with the image given here. What you are observing here, if you are entering the electrons in an order like this. So first we need to enter the electron in the 1s orbital. Then it will be moving to 2s orbital, then 2p orbital, then 3s orbital, then 3p orbital, then 4s orbital, then 3d orbital. Which means that the electron is entering into 4s before 3d, right? If you are writing the electronic configuration like that also, which means that the first electron is entering into 4s. Then only it is moving to 3d orbital. Clear? According to Aufbau principle. That is why here the last electron is entering into the d subshell, so it will be considered as a d block element. Okay, here is our next question. The lanthanum belongs to which block? So when you are focusing on the periodic table, you can say that one element is present there, right? It is have the symbol of La, lanthanum. So which block element it is? Yes, it is option 3, right? Which means lanthanum is a d block element, because last electron is entering into the D subshell. But after lanthanum, all the 14 elements is considered as the F block elements, in which last electron is entering into the F subshell only. Clear? So option 3 will be the correct answer here. Here is the next question. The electronic configuration is given here. We need to identify the atomic number of the element which is just below X in the periodic table. So just take it as a homework here. It is a simple question. Already from the electronic configuration, we can take in the atomic number of these elements, right? Now from the periodic table, we can identify the which is the next element just below to this element, right? So I will give you the answer first. It will be option 1. Try to find the answer for this question. So that's all about from my side for today. We have discussed about the introduction to modern periodic table, right? We have seen the nomenclature of elements having the atomic number greater than 100. Now we have seen about the classification of elements, right? We have classified the complete periodic table into 7 horizontal rows known as the periods and the 18 vertical columns known as the groups. Now we have seen the electronic configuration of those elements in the periods as well as groups. Then we will be moving to the classification of elements into different blocks like S block, P block, D block and F block. And finally we have discussed about how to find the position of an element if you are getting the atomic number of the electronic configuration, to find the block, to find the group and to find the period, right? I hope you understand about the session. If you really like the session, hit the like button, share this session to your friends also, and subscribe our channel Infinity Learn 9 and 10 YouTube channel. If you want to get the session PDF, you need to join our Telegram channel, Infinity Learn 9 and 10 Telegram channel. So thank you so much all of you. See you in the next class. Bye bye.